and I'm one of the instructors here at Sinclair College's automotive program. And we're going to step away a little bit from our consumer-based videos and actually do a little bit more technical videos. For those of you that maybe are automotive service technicians or do-it-yourselfers and you're looking at maybe becoming a service technician in the future. And what we're going to talk about a little bit today is called parasitic or ignition off draw. And so the customer complaint typically in this situation is the vehicle sits for maybe half a day, maybe overnight, and the battery goes dead. And so what we have going on is we have a parasite, a load, an electrical device staying on when the key is in the off position. And this can be caused by many different things, and we're just going to go ahead and go through the general steps. As I've always mentioned, there's a lot of different ways you can do this. There's a millivolt test that you can do voltage drop across fuses. There's the old test light trick that you can do in line instead of using your ammeter. So inductive amp clamps. Today I'm going to show you how to use a digital volt ohm meter or an amp meter, and we're actually going to measure the current draw through the negative battery cable. So I'm going to explain here kind of what's going on, and we'll go back and forth between the car, the vehicle, and then also the board to kind of explain this. So here's what we got going on. When we're doing this, an ignition off draw is caused by something where there's a load that's on that's not supposed to be on. So I've kind of drawn a very general schematic, and it's not a representation of the vehicle that we're working on, but I've provided some loads with some different fuses. And what's going on is one of these loads is being turned on when it's not supposed to. Sometimes that could be a body module, like a heated seat module, it could be a liftgate module, it could be a variety of things. Could not even be the module's fault. It could be a switch input telling the module to wake up when it's not supposed to be awake. And so what we're trying to do is eliminate possibilities. And so the first step that I would make sure is that you have a good charged battery before doing this test. Narrow it down that you're pretty sure that there is something causing the vehicle's battery to go dead overnight or maybe over a couple of days time frame. If a vehicle sits for extended periods of time, so 1 to 2 months sometimes, that's enough for the natural memory in vehicles to have them go dead. So we have a powertrain control module, we have radios, and that some of those are expected to have some type of amperage pool whenever the vehicle is just sitting. So it's not great on vehicles to let them sit for 2 or 3 months. Ideally, you would start those vehicles up, let the batteries get charged maybe every 2 to 3 weeks. That time frame may differ, but you definitely want to keep the vehicles charged so that your batteries don't go dead. The first thing that we'd want to do is take a walk around the vehicle to look for any aftermarket devices. What I mean by aftermarket is something that the vehicle wasn't built with. So I'm going to give you some possibilities, but it's not limited to those. That could be some things like remote start systems, amplifier kits for car audio systems, plow kits. If you're in the first responders, those could be any accessories that come on a police cruiser or anything like that. So what we're looking for is like a plow truck maybe that has some cabling, any device that looks like it wasn't there. And the places that I would look, of course, is close to the fuse boxes, so under dash and under hood. I would look underneath the vehicles, so a lot of times like lighting, additional lighting, maybe some trailer connectors. I would look for some of those devices to see if any of that, because a lot of times it's nothing that the vehicle has on the vehicle that's causing the concern. It's as simple as somebody didn't wire up the aftermarket system correctly, causing that issue. So many vehicles can be fixed by just looking for those things. The other thing that's very common today is that you're going to see is a lot of iPhones, iPads, whatever phone that you have is going to be charged, cellular phone being charged in the vehicle. And we have different styles. We have 12 volt switched accessory, and those come on basically whenever you turn your key on, and they're only charging when your key is on. We also have 12 volts battery or 12 volt hot at all times, and those devices in the rear and center consoles, in the rear seats, middle seats, those are actually going to be what we call hot at all times, meaning they have battery power to them at all times. So what can happen is mom or dad or grandma or grandpa will have a tablet that they're charging for maybe a young child, and they leave it in the vehicle for a couple days and they forget about it, and that actually causes the vehicle's battery to go dead sooner than later. And so those are some of the things that we want to look for. Any dome lights or any lights, glove box lights that may inadvertently be left on. Maybe a child hit a dome light in the vehicle and turned it on, and the vehicle doesn't have the ability to turn those off through the module automatically. So we're going to look for simple things first before we dive into this. I will tell you that this can be a very long process because there could be some small intermittent concerns. So if you're lucky, you're going to find an aftermarket device that may be causing your issue. In this case, we're going to probably rule out that that's going to be our issue, and we're going to show you the steps to get this done. All right, so what we're going to do is we're going to use our meter on the ground side. We're going to use a DC amp meter. So we're going to be taking our red lead, putting it in the amps hole, and we're actually going to be putting it on the ground side rather than the power side. So we know that any current that's going through any of these devices that are staying on has to return in through the ground path. And so what we're going to do is we're actually going to use our meter across this ground cable. We're actually going to use jungle wires to put our meter in series with the ground to the negative post. And so ultimately the current that is flowing through here is going to actually go up through my meter, back in and into the negative post, and that's going to give us our observation. Typically what we're looking for, a generic spec. This can change from vehicle to vehicle, manufacturer to manufacturer. We're working for 50 milliamps or 0.050 amps or less to be causing that to be a good. Anything higher than that number, that's going to be bad, and we're looking for a parasitic device that's staying on when it's not supposed to. So let's go ahead and get started on the vehicle. So we have our interior lights on, and one of the things that we're going to do is actually trip our door latches for not only all of the doors on the vehicle, but also for our lift gate. And so I want to show you before we get started here, we're going to access, this is where our door switch is that tells us that our door is closed. Sometimes they're in other locations. On this vehicle, it's part of this. So what we're going to do is we're going to take our screwdriver and we're going to roll it so it's all the way locked and latched. And what will happen after a few moments here, a minute or two, is that light will go out. We're going to do this for all 4 doors. We're going to do this for the lift gate, and also we're going to have to do this for the hood. This allows us to get inside the vehicle to pull fuses in the future. So just to recap, what we're going to do is I'm actually going to take our key and take it and set it on the workbench away from the vehicle. Reason being, on new vehicles, we have a lot of systems that have like passive entry, and the key will be recognized when it's inside the vehicle or close to the vehicle. So we want to make sure that that module is not being awake when we're doing this test. The other thing I mentioned is we talked about aftermarket accessories, and you can see that this vehicle has 2 cables going directly to the battery. Here at Sinclair College, one of the things that we do is we have chargers to allow our vehicles to make sure that the batteries maintain charge. I have disconnected to make sure that that is isolated, so this is not going to a load. If you were in doubt, what I would recommend is disconnecting the ground path from the vehicle to make sure that you don't have any issues. So right now, I would visually look for any other aftermarket accessories tying into the battery or potentially the fuse box. So to recap kind of where we're at right now, we've actually went ahead and tripped all door latches, the lift gate latch, also the hood latch, and we've tried to look for any lights that could have been left on. We've removed the key, placed it on the workbench. Now what we're getting ready to do is connect our meter in series with the ground cable. So we're going to get ready to move on to that. So there are devices out there, they're actually called a battery drain switch that you can use. A lot of folks use those on RVs and maybe boats and other classic vehicles that stay stored in the winter to open up the circuit between the negative post and the cable. They can be purchased for about $15 from your local parts store. They're very good. Today I'm going to show you how to use one without it, because a lot of techs out there in the industry are not going to have that. So what we're going to do is we're actually going to disconnect this. Sometimes the manufacturer will tell you to drive the vehicle for 20 minutes in order to wake up any modules, and then to let it sit until those modules go to sleep. Those modules have an internal timer that will time out after a certain time length or duration. So we're going to go ahead and connect our meter now. And the first thing that we're going to do is we're going to make sure that our red lead is in the amps hole. This is super critical. A lot of people think that we're going to be going across the positive and negative terminal. That is actually incorrect. A lot of students coming through our program, that's the most common mistake they make. They're going to put their red lead to the positive post, their black lead to the negative post, and what that's going to cause is the direct short from the from the positive to the negative, and blow their fuse inside their meter. And so we're going to change this to the 10 amp scale, and we're going to be set up and ready to measure the parasitic or ignition off draw on this vehicle. So I'm gonna go ahead and disconnect our negative. Again, the reason I'm doing the negative, you could do the positive side. The negative is safer. That way, if you have a wrench that slips and it touches ground to here, there's no concerns there. So we're just doing this for safety reasons. And we're gonna have to wiggle this up there a little bit. Sometimes these clamps get a little bit tight. And so now we've opened up the circuit. And what we're going to do is we're gonna take our jumper wires, and this is gonna be kind of critical is that that post doesn't touch. We're going to take a jumper wire here to my meter lead. And although you might have your leads the polarity reversed here, and this is going to be low current, so probably less than 10 amps, we're hoping. We're going to take our other lead with our jumper wire. Next thing that I want to try to do, if I can, is I want to connect my other alligator clamp to my post. The challenge with this, as you can see, is that I can't get this on there. So instead, what I'm going to do is I'm actually going to use one of these parasitic draw switches. Now you could just put your meter lead up top here, but the problem is we want to be able to free your hands up. So here in a minute, we can start pulling fuses and relays out to access this. So what I'm going to do is I'm going to place this switch across here. And all I'm using this for is to allow my alligator clamps to actually connect easier to that cable. And so the other end is going to go to my meter. Now, once I do this, it should get a reading. That is, if my fuse is good in here. So I'm on DC amps, I'm gonna connect this, our meter should jump up, and lo and behold, the problem is right now, I'm not getting a reading. However, I know I have a parasitic draw. And so this tells me that likely one of my fuses is bad in my jumper wires, or my fuse is bad internal to my meter because I made a wrong measurement in the past. So what we're gonna do is I've already verified that the fuses in my jumper wires are good. What I'm gonna do is swap up my meter. This is very common if a technician is not paying attention, and as I mentioned, they can go across and make the wrong measurement. They blow the internal fuse to this meter. So what we would need to do is disassemble the meter, replace the fuse, and then redo our measurement. Instead, for this exercise, we're gonna grab another meter. So I went ahead and got another meter. We're on the red DC amp scale. We're gonna switch over to amps or milliamps. All right, so we went ahead and got another meter. We're on DC amps. We're gonna put the red lead into our amps hole, our black lead's in the common. And what's gonna be happening is we have current basically coming out through our fuse jumper wire. So we're gonna connect one lead here. The other lead is gonna go back into the cable that's actually going into my ground cable. Had a loose connection there. So we just wanna make sure. And it looks like we're getting about 3.4, 3.7. And so we're gonna wait till we get the lowest measurement possible. So this says 3,000 milliamps, which is actually 3.6, 3.5 amps. So we got a pretty excessive draw right now. And that's definitely a concern because we're looking for 50 milliamps or less. And so the next step of this, now that my hands are free, and that was the reason for the alligator clamps. And so I'm gonna recap. What's going on is current is leaving our positive posts. It's going to a load. It's going through the chassis ground and the body ground. It's coming up through my cable. It's going through here, through my meter, all the way back out. Your meter's connected in series, back into the negative post. So the only reason for the jumper wires is, again, so you can free your hands up. So you can see that right now our amperage draw has actually decreased to about roughly 500, 450, but what we need it to be is less than 50. So now what we would do is we would start pulling fuses one by one. The first thing that I would recommend is that you would take a look at your fuse box cover and make sure that they tell you which fuse goes where. The next thing that I would recommend doing is taking out your cell phone and taking a picture of the fuse box. And the reason being is once we're done, we need to make sure that all the fuses and relays go back into the correct spot. So I take a picture, and then that way, whenever we're done, we can pull it back up and put the fuses in the correct orientation when we're done. And so now the next thing that we're going to be doing is I'm going to take relays and fuses and pull those out one at a time. And when I take one out, I'm going to be looking for this to drop below 50 milliamps. And we're going to take them and leave them out. If you put them back in, what's going to happen is you're likely going to wake up a module or a component or a load, and you're going to have to wait until that module goes back to sleep. So we want to do this very efficiently, as fast as possible. So I'm going to grab some needle nose and I'm going to start pulling fuses one by one. What we're going to start doing is pulling fuses one by one. And so I'm going to use these pliers. I've noticed that these blade fuses are a little bit easier to pull out. Some of these newer fuses are a little bit more challenging, so I'm going to pull those out first just because of the ease. So I'm going to pull that one out. No change on my meter, so take a look at it, stays about the same. We're going to go to the next one here in the bottom left hand corner. I'm just setting them back out to the side. I'm not putting them back in. Again, hardly any change. Hardly any change. Again, just setting them back out. Keep pulling. All right, and so that one has a drastic drop. And so what we're going to do, even though it's not below spec, we want it to get closer to the 50 milliamps. And so that still have a little bit of a concern there. And what we're going to try to do here is we're going to see on our fuse box cover on what that fuse feeds. So we can either go to service information or look inside here. It's going to be very challenging to see this, but once we locate this, that is going to be fuse, judging by the cover here. So that's actually fuse 60. So it's actually that one right down there. And what we're going to do now is we're going to go on service information and look up what fuse 60 feeds. So now we have to go to the computer and see what it feeds. You can also look on here, but for this purposes, we're going to go over to the fuse box. We're actually going to find out what fuse 60 feeds. So let's go over there. All right, so the next thing that we're going to do is fuse 60 is the fuse that's causing the concern. It is feeding the power circuit. So by disconnecting that fuse, what is happening is we're opening the circuit, therefore the load cannot actually draw any current. So what we're looking for is actually we're going to be going into, for a 2015 Jeep Cherokee Trailhawk, we're going to be looking for wiring diagrams. And so we're going to go into wiring diagrams here. We're going to use, you can use either Mitchell system diagrams, or I'm going to actually use the system wiring diagrams that are from the vehicle. And we're going to be looking for power distribution. And so as I navigate down here, this is alphabetical. And what we're looking for is the power distribution. So we're going to click on that. And now what we're going to be trying to find is fuse 60 on our diagram. So this is why this takes a little bit of time, because you have to dig through. Now if you found a diagram that said fuse 60 on it, you could certainly navigate to that directly. So none of these fuses are what we're looking for, so we're going to continue to scroll down. None of these are the fuses that we're looking for. So again, we're looking for fuse number 60. And as you can see, we find it here, and fuse number 60 is a 20 amp, that's correct. And as we scroll down, what we're going to look for is to see what it feeds. And the component that it actually feeds is the console for the power outlet for the console. And so now what that tells me is that something on this circuit is likely causing it. So I'm going to navigate to that, and there is only one load on that. And we're going to look back at our board here in a few minutes and talk about it, what other things could be a possibility. So let's go back to the vehicle, and then we're going to regroup and talk about what we have found. So I want to recap of what we have done. We've gone to the power distribution for the schematic. We found that fuse 60 is our concern. It feeds our 12 volt outlet inside our console. One thing you did not see me do is I pushed the fuse back in, and the reason being is we're going to try to see if that is the load that's causing the issue. The number on the meter went back up to the 370 milliamps that we had, and we're actually going to locate and look inside here. The other thing that you're going to notice is that I'm able to keep my door open without having my dome light or my interior lights on. So that's one reason why we tripped all the latches, is that we want to be able to access the vehicle for fuse boxes, for loads. And if we open that door, what would typically happen is all of our interior lights would go up and would wake up modules and also cause a higher current draw. So that is the reason in the preconditioning steps that we tripped all door latches. So if I open this console here, you'll notice that I have, as a good instructor, put a bug in the vehicle. Now, this is just a light basically, and this is not an actual cause of concern for a customer, but what it does simulate is a couple different things. It can simulate the fact that we have a tablet that's charged in here that's been sitting. So this is a accessory outlet that has 12 volts to it constantly, like I talked about at the beginning of the video. It also simulates that if someone had a glove box light that is partially on because their owner's manual is keeping the switch partially jarred, that could also keep like a glove box light on. So what we would do now is we'd actually disconnect the component or disconnect the load connector from the back side of this. And so we're gonna go ahead and disconnect this. We're gonna go back out to our meter, check the reading, and my guess is we're gonna be close to that 50 milliamp general spec. So if you remember, this is fuse 60. I put the fuse back in. With the load disconnected, you'll notice that my meter reading has dropped down to almost 80 milliamps. And it kind of is fluctuating between about 80, sometimes down as low as 65. Now, I intentionally put a bug in this vehicle, if you will. So there's still a slight draw on this. What I would expect is that this would probably, after a little while, drop down below 50 or 40 milliamps, and this vehicle does not actually have a concern. And so what we would do now is, and again, this simulated scenario, we would disconnect the load. This vehicle will now be an issue. We're gonna revisit some other possibilities on the board as a recap, but now what we can do is we can go ahead and place all the fuses back in. I would go ahead and maybe let the vehicle sit for a few hours before we return it to the customer and make sure that we have no other parasitic loads and that this is an acceptable measurement. Again, sometimes it's around 35 to 50 milliamps. The more modules, the more electrical accessories on the vehicle, it's likely to have a higher draw and a battery that has the capacity to retain that ignition off draw. So let's go back to the board and do a recap before we close this session. I want to recap kind of what we did here. And that is, we placed your meter up in here with our negative battery cable. I actually disconnected and opened it, and that way any of the current from one of these loads was actually coming up through here, through the negative connection, through the ground cable, up through my meter. It was reading around 3,800 milliamps, right? And it was then coming in here and going back into my battery and then going back out to the load that was turned on. And so in this scenario, we're gonna assume that fuse number 3 here is actually fuse number 60 in the car. And in this case, we're actually gonna have, instead of just having one load, which is our 12 volt accessory outlet for a console, we have 3 loads connected to this. Well, how do you narrow it down? The next thing that we would do is we would have to actually put the fuse back in that was causing the issue. So that would have been fuse 3. Our reading would be going back up to the 3,800 milliamps. And then we would disconnect one of these components individually to watch this number drop. In this scenario, if I'm a flat rate technician, I want to find the easiest device to disconnect. And so in this case, if the amplifier was the easiest one to get to, I would physically disconnect the power plug or ground plug to that device. In this case, most likely it's going to be a 12 volt accessory. So what we are actually trying to do is to open the connection, that way no current is being drawn. And in this scenario, what would happen is that my meter reading, instead of being 3,800 milliamps, might go closer to 65 milliamps. Now that's still above our generic spec, but we would also try to narrow down to see if there's any other concerns. And so my recommendation is, when trying to isolate this, go to the easiest one first. So if that means that to get to the radio, you have to pull out the center stack and it takes 20 minutes, and this takes less than 30 seconds, you'd want to go with this one first. If the measurement didn't change, we would then go and disconnect the next component until we isolate the draw. So this is how you go about finding a parasitic draw, or what they call an ignition off draw. And again, our spec that we are usually looking for is 50 milliamps or 0.05 amps if you do the conversion. And so hopefully this was a nice review for you. For those of you that are becoming service technicians, this is always something that's challenging for students and techs to wrap their head around. There are multiple ways to do this, and this is just one of the few ways that you can go out there. And I'm sure that there's some different steps that some of you might add in that we want to do in the future to make this more efficient, or to make sure that we are narrowing down our cause. But this is a general overview of how to do what we call parasitic or ignition off draw. Thanks so much.